Good morning, class. Today is Thursday, May 14th. Let's begin with some science this morning. Today we're going to be doing the Ocean Solutions STEAM PBL Challenge. Again, it's the next page in your Ultimate Science Notebook. Can't stress this enough. If you want to be really prepared for middle school, a great way to practice over the summer. We're not going to get to either the outer space or the cells unit. And I know you're not going to be able to do all of the labs, but any of that work that you want to do to practice science and to work over the summer is totally okay, and feel free to use that book as you see best. I highly recommend you keep your Ultimate Science, Ultimate Language, and Ultimate Math notebooks at least until the end of next year so that they can help you with any questions or confusions you might have. A lot of students have told me in the past that they've kept their notebooks for a really long time and it's helped them in many years to come. So just kind of keep that in your mind. If you have two options to do this PBL STEAM challenge, you can either do them entirely by yourself. So pause this video, just do the PBL by yourself, no problem. The other option is you can do the 4 components with me in this video. So it's your choice. You can either do the whole STEAM PBL on your own, or you can do it with me right now. Let's get started. So if you're following along with me in the video, we're going to choral read, which means you read as I read at home, even if it sounds silly. We're going to read, including the title, in 3, 2, 1. STEAM PBL Challenge, Ocean Solution, Introduction Story. Waffles and Donut were going back out to the ocean with their mom, Megan the scientist. They packed up 2 wagons, one with scientific tools and instruments, and one with toys and food for the 2 dogs. Yep, Waffles said. She loved jumping around in the ocean waves as they wiggled around her belly. Ruff, Donut said. He was more of a sit on a warm towel in the shade and relax kind of dog. He liked going to the ocean for one reason and one reason only: dog treats. Megan always packed extra dog treats when they went out for picnics out into the ocean. Megan the scientist laughed. Me too, she said. Megan always had a way of understanding what her dogs meant when they were barking, as if they were a 3-person conversation. I'm excited to go to the ocean too. My lab wants me to collect some samples to see how increases in power plant pollution have been affecting the pH of the water. Ruff, Donut said, which probably meant something like, as long as there are extra dog treats, I'm in. When they got to the beach, it was deserted. Megan got out her tools and went to the water to start collecting samples at different sections of the beach. She let Waffles and Donut go, keeping an eye on them while she set her tools and collected data. She sent a sample drone to collect water from further out, where it got deeper, to get a better picture of the entire situation. She was collecting her last sample when Waffles came over and started peeing next to where Megan was standing. The water started to feel warm. Waffles, she said. Yep, Waffles said, not even really paying attention as she excitedly kept jumping around in the waves. Silly dog, Megan said, patting her on the head and sealing the lid to the last sample. As they were driving home, Megan was humming and happily thinking to herself, "Oh no," she said, "I mixed the sample where Waffles peed in the ocean with the others. Now my experiment is ruined." "Yep," said Waffles, which meant something like, "I'm sorry, I just like jumping in the ocean, and you know that always makes me have to pee." "Ruff," said Donut. "You better not have ruined this for me, Waffles. I like my relaxation and extra doggy treats at the beach time." "Don't worry," Megan said. "This just calls for science." So we are now going to do the language, arts, and science connection. So you're looking at the chart below with various information present. Fill in the blanks and write which one you think they are by circling the multiple choice. Okay, when we look at this chart, there's a lot of information on here. First thing I want us to do when we see a chart that looks overwhelming is we take a deep breath. Now we're ready. Never freak out when someone gives you something difficult. Always face that challenge. So this might look a little confusing, but let's think back to the story. We know that Megan the scientist collected 4 samples. So she has her 4 samples, and then the other columns are all the other pieces of data she collected about those 4 samples. We need to use that information to figure out which sample is which. So, sample 1. I'm going to try zooming in. So some of the visual observations say some sand mixed into the solution, translucent, murky. Translucent means we can, transparent would mean we can see completely through it. Translucent means that it's a little sandy, it's a little murky. It's basically just a way for saying like murky or we can't see all the way through it. The temperature is 25.5 degrees Celsius when collected. The presence of photosynthesizing plankton. Yes, the sample has the most photosynthesizing plankton of all collected. Ooh, that tells me a lot of information. This has the lowest salinity of all the samples collected. So which sample is this? Is this A, the sample waffles peed in, B, the sample from the shore, C, the sample from the middle of the continental shelf, or D, a sample from the edge of the continental shelf and the slope? So what you need to do, I'm only going to read the first one out loud because I don't think you need me to go through each one by one. Feel free to pause. So sample 2 was very murky, discolored, 30 degrees Celsius, no photosynthesizing plankton, high salinity. Sample 3, clear with pieces of dirt and darker pieces, 20 degrees Celsius, has the least photosynthesizing plankton collected, highest salinity. Number 4, very clear, almost transparent solution, 10 degrees Celsius. There's a medium amount of photosynthesizing plankton collected, medium amounts of dissolved salts in the solution. So you need to kind of guess, do these represent mixtures or solutions, and how do you know? So remember, if it's just pee, if it's just pee and water, if it's just salt and water, those are solutions, right? Because we expect those solids to be completely dissolved. If it says it's murky, translucent, things like that, and we can see particles of sand, dirt, and rocks, then it's a mixture, right? Why do we use Celsius in the data collection? Remember, we're using science, and Celsius is part of that metric system. Which of these was probably collected in the area with highest pressure? So remember, as we go deeper in the ocean, things get more dense. Also remember the pressure increases. So temperature decreases, pressure increases, life decreases, salinity increases, density increases. So for the art connection, based on the information in the table you were given, draw the beach and of course Megan Waffles and Donut, as well as the continental shelf, slope, rise, abyssal plain, and label each. Also label the continental margin. Add in the terms, highest salinity, lowest salinity, highest pressure, lowest pressure, most life, least life, highest temperature, lowest temperature, sunlight zone, twilight zone, midnight zone. So I'm going to do like kind of a mock drawing of this. Is obviously not going to be super great because I am not a super amazing artiste here. But let's see. So I'm going to start, I'm going to draw my little beachy area, my continental shelf, my slope, my rise, and my plain. So if I'm drawing this first, that's kind of the continent. Now I'm going to draw it in the water. I'm going to draw waffles, and I'm going to draw, or no, that's donut. I'm going to draw waffles in the water and donut out of the water. And I'm going to draw Megan the scientist. Remember, up here would have the most life. And then down here would have the highest pressure, density, salinity, etc. Remember that our midnight zone should be darker and bigger than our twilight zone and sunlight zone together. That's kind of the main things. Everything else you should be able to look back in your textbook to find answers for, but this is in general what it should look like. Again, I'm not a great artist, so I hope your drawings are better than mine. For our novice math collection. Okay, so I'm going to do these ones with you. Please follow along in your Ultimate Science notebook or on the spare sheet of paper if you do not have yours. For warm it says, in the sample that Waffles peed in, 63.2, and I'm already writing this down. Nope, I wrote my 6 backwards. 63.2 percent of the sample was ocean water, and the remainder was Waffles' urine. What percentage of the sample was Waffles' urine? Okay, so what does percent mean? And remember, we've done this a lot of times, especially when calculating our attendance. Percent means out of 100. So we have 63.2% or 63.2% out of how much? 100. So what I need to do here is I actually just need to subtract 100 minus, and remember, most important thing when adding and subtracting decimals is we line it up, line it up, line it up, at the decimal. So My imaginary decimal would be there next to my 100, lining up my decimals here, right? My 2 goes here on the other side, my 3, and my 6. Now, I cannot subtract backwards, so I'm going to do this the right way. You do this with me. So I have 100 minus 63.2. All right. So I can't do 0 minus 2, so I need to borrow. This becomes 10. I need to borrow from my next one, so my 10 becomes a 9. I need to borrow from my next one, so my 10 becomes a 9. My 1 becomes a 0. This is what that looks like backwards, just in case anybody needs that visual. So 10 minus 2 is 8. I'm ignoring my decimal for now. 9 minus 3 is 6. 9 minus 6 is 3. And 0 minus 0 is nothing. So now what do I need to do? I bring it down. I bring it down, bring it down. So my answer here is 36 and 8/10. Now that's my dog. So now how can I double check my answer? If I add these two together, they should equal 100. Puppy. Okay, so our next question says, our harder question says, when they go to the beach, Donut likes to eat a super scrumptious treat every 30 minutes, just like my pug is howling out the window. If Megan the scientist allows it, if he ate 6 dog treats, how long were they on the beach? And I would normally try to stop my pug, but since our story is about pugs, it seems minorly appropriate, and there's absolutely nothing that will pacify her this morning because the lawnmower is on. So I'm going to say each of these boxes represents 1 treat in 30 minutes, okay? So I'm going to go 1 treat, all right? 1 treat. So how many treats do they have? They have 6 of them. So we have 6 30-minute segments. So I have 30 minutes for 1 treat. 2 treats is another 30 minutes. That makes 60. 3 treats, that's another 30 minutes. That makes an hour and a half. Another 30 minutes. That equals 2 hours. So I have 1, 2, 3, 4 treats. I'm going to show you my progress. So this is what 4 treats looks like. It's 2 hours. I'm going to add 2 more treats. That's 30 and 30. So in total, my time is, and I can count by every 2 30s equals 60, which is an hour. So 1 hour, 2 hours, 3 hours. So my answer here should be 3 hours. Pretty cool, huh? All right, and then my hardest question says, Waffles sheds 250 hairs per day on average. Donut sheds 300 hairs per day on average. In the course of 7 days or 1 week, how many more hairs would Donut shed than Waffles? Okay, so for this particular question, I need to draw a bar diagram, and I chose to do a condensed bar diagram like so, with the dots in the middle. So I see, I think it was for Waffles, yeah. Waffles sheds 250 hairs per day on average, right? And we're multiplying it 7 times because this is 1 day, 2 days, 3 days, 4 days, 5 days, 6 days, 7 days. Donut, on the other hand, sheds 300 hairs per day, which now that I own a pug, I realize it's probably much more than that. It's insane how much they shed. 300 once, twice, 3, 4, 5, 6, 7 times. So we can either do repeated addition or we can do multiplication. It's actually pretty easy multiplication if we remember our song. If I must multiply 2 whole numbers with zeros, multiply the front digits like normal and add the O's. This is because we're just moving it over in the place value system. Because it's base 10, each 0, 10 just moves it over 1 space to the left. So all I need to do here is multiply 25 times 7 and add a 0. 3 times 7 and add a 0. Let's do 3 times 7. 7, 14, 21. So this would be 2100, 2,100. 25 times 7 would be, so this would be 175. Add a 0. So then that'd be 1,750. So now I need to figure out how much more it is. So I subtract 2,100 minus 1,750. I want to show the answers because I only have 15 more seconds left. So sample 1 is B, sample 2 is A, sample 3 is D, sample 4 is C. This is what your picture should kind of look like. Feel free to pause. And this is the answer to our math questions. Thank you so much for joining me. Have a great afternoon.